Good evening, sir and classmates.
Hey, Alvin, how you doing?
Not too bad, sir.
Good, good. All the rest of you. Adrian and Lecarno, wanna code?
Even so, just got in from work.
No, okay, no problem.
Good afternoon.
Afternoon. Can you just touch base with your classmates, please, students, and let them know that they need to join soonest? I don't think I can afford the 15 minutes tonight because there's so much to be done. So touch base again, please. All right, students. So what I have projected, I believe, is a question I gave for homework last class. True or false?
Yes, sir.
All right. How many of you gave an attempt to the question?
It is same time, sir.
Attempted it, sir.
Attempted it. Nice, Christian.
Same here, sir.
Good job. Okay. I see you talking to me tonight. I'm very nice. I love that. Who else is here? Kenneth, I don't hear from you. All right, so what is this? This is 21. Okay, this sounds like it. It's 20. Christian is here twice. Alvin, did you do the homework?
Yes, sir.
Yes, sir.
Yes,
Good
sir.
job, good job, good job, good job, good job. Oh, you can't miss your twice as well, so it's 19. All right.
Sir,
Yes, please.
I have a question about the homework, sir.
What about you?
So if you say you have two x's, right? Two x values. Is it a case where you have to work out both of them, sir?
I don't understand the question. Ask again.
So considering we have -4 and 1, and we find the suitable condition for it, is it a case where we have to work out both values when you substitute them into the equation?
Yeah.
Okay, sir, thank you.
It's two different conditions, you know. I want to find out if it is continuous at x equals -4. And I'm also trying to find out if it is continuous at x equals -1. Sorry, +1.
Okay, thank you, sir.
No problem. Okay, so go ahead, Taj.
No, that was a mistake, sir.
Okay. No, okay. So since you play a mistake on me a while ago, Taj, what do you give it at x equal -4?
X equal -4, it is continuous, and we're looking at 1.
Okay.
Yes, we're looking at 1. X equals
What do you say at x equal 1?
X equal 1, it is also continuous. X equals 1.
What the limit tends to?
Here,
Say that again.
I'm looking back at my notes here, sir. Limit tends to at x equal 1. That's right here. The limit tends to 11, sir.
Okay. Very nice. Are we okay? Did everybody get it to be continuous at x equals -4 and x equals 1?
Yes, sir. Yes, sir.
Good job. Yes, please.
Yes, sir.
Nice. Is there anybody in the class that did not get it?
Yes, sir.
Sir, I have a question.
Go ahead.
I think I mixed up the part with the positive and negative sign. My 2x plus 9, x tending to -4, the signs are incorrect. Can you just go over how we allocate the signs again?
What signs are you talking about now, Christian?
The plus or the minus, if it's tending to the right or turn to the left. Because I thought I understood the concept, until I saw that your 2x plus 9 is tending to -4.
All right, so it says when the limit tends to, when it's to the left of -4 is when it is going to be superscript minus, don't. The left means negative, don't.
Yes, sir, it's going down.
It's, yeah, or to the right. Good. So it means that when I'm looking at to the left of -4, I have to use a half x plus 3, which is this function. When I'm looking to the right of -4, I have to use this other function, 2x plus 9. Two x plus 9. Follow what I'm saying?
Thus far, I think.
When I'm looking at x equals 1, to the left of x equals 1, see here, x is less than or equals to 1. To the left of x equals 1, I have to use 2x plus 9. So to the left of it, see here, I have to use this one. And to the right of 1, there is only one that I can use, is 11. And remember, the limit of a constant is the constant itself. I did something like that in class. I asked a question like that in class, and I think you guys got it. So I'm happy that you got the second piece here to be continuous as the limit tends to 11. All right, and May was coming in. Was that Evan or was that Mason?
Sir, I not too long came in.
Okay.
Sir, me have a question. Oh, that
Okay.
me still not get the first one there, but me have the second one correct, the 11. But me don't know how you get that 4. Me I try look for it, but me not get it.
What 4 do?
Since the continuous at x equal -4.
That's a question.
Oh, so me I wonder me I'll put something wrong. Oh, yeah, me get the 1 right here, so 11. Oh, now you, then me I wonder where the 4 that come from. Because me have the same thing there. Me think of 4, you there said it was the answer.
Go put on some tea, man, and burp to guess. Nigel.
Evening, sir.
Easy.
Go back to the question, sir. Scroll up a little. All right. So I think my issue is you have X determine if G, oh, you read that, sir?
G of X.
G of X, right, is continuous at X equal -4, right? But in the equation itself, you have half X plus 3, and then the line below that, you have 2x plus 9, but both of them have -4 in it. So am I to work the equation x equal -4 for both of those?
I don't want to look at it like that. You have to decide which is which. The condition says x is less than -4. When it is less than, it is to the left. That means this is to the left of -4, and that's why I have this -4 to the left. That's superscript.
Yes, sir.
Right, for this function. So if you had used the other function, even though you get the same result, because the statement is incorrect, you wouldn't get full marks.
True.
All right.
All
So
right.
you
What
have
did
to
I
use the
think it, sir,
conditions.
but okay, got you.
Any other questions?
Oh, sorry.
Okay. All right. What do I do? All right. Go through that one for me, please. I want you to try as best as possible to work the question, work them on your own. Don't be slavish to go back and look in the book, because at this point in time, you should be able to work the question from memory. I also need for you to master what is happening here, because in tonight's class, it is my intention to compound this topic by putting some unknowns in there for you to calculate. So it is imperative that we have an understanding of what it is that we're doing. So I give you 5 minutes to work that one for me. Thank you.
Finish, sir.
Good job. The rest of you, please hurry.
Finish it, sir.
Yes, sir.
Good job. Giving you 2 more minutes, guys.
Sir,
2 more
can I get
minutes.
2 more? Thank you.
Yeah, 2 more minutes.
Finish, sir.
All right. So tell me now. What? Was it continuous at x equals -2?
No, sir, because the functions are
No, sir.
Yes, sir.
They're not equal. Okay, what did you get for the function? What they're equal to?
Sir, for the left hand, which
Mhm.
is limit x, so -2, negative, I got 1, and for the right hand limit, it was -1.
Okay, cool. And I like what it is that you spoke about it. The left hand. So the mere fact that you say left hand, you never had to read what it is. In terms, but when it said the limit x tends to -2 minus, because that already in and of itself means the left hand. So I like the grown-up way of telling me what it is. Very good. So yes, you are correct. The left hand limit is equal to 1, and the right hand limit is equal to what?
-1.
-1. God says discontinuous. All right. Was it continuous at x equals +2?
Yes, sir. Yes, sir.
How?
Sir,
Okay, explain.
left hand was equal to -1, and the right hand was also equal to -1.
Big up on yourself. Is there anybody in the class that is having a challenge understanding what is taking place? I don't want to hear when I'm finished. That's also I don't understand. Go ahead for me, please, Nigel.
All right, so we'll get the +1 for the right side and the -1 for the left side. What Ashanti has said. But we never get the same thing for the continuous part, sir.
I'm gonna get the same thing for where when x equals to +2.
Well, on the sir. Internet not so strong. Repeat what I said, sir.
I'm not following what you're saying. You never get the same thing for. Never get the same thing where.
All right, so when Ashanti mentioned the left side equal 1, and the right side is, sorry, left side equal -1 and the right side equal +1. But get that. Because I think we did send you in the chat, say discontinuous. But you did ask.
But hold on there now. Except though that Ashanti have it the other way around. So do I. The left hand limit was equal to +1, and the right hand limit is equal to -1.
All right, so maybe may I read it wrong. So I have limit as x tends to 2 superscript negative.
That's the left hand one.
That's the left hand. I'm gonna get +1 for that, sir.
And you're correct now.
Okay. But the 5x, something the way you have this, so never get
where at x
where
equals
the
2.
superscript
The
2.
jargon, you know. Have to speak the jargon now. Where at x equals 2?
Yeah, so 2 superscript positive, sir.
All right, so
which is the
Mason,
second function that you just worked out.
Hold up, Mason, hold up. So what is the same thing I was trying to get Logan to do in terms of calling the correct terminologies? Is the same thing now that I'm going to be on you now, Mason, to speak the correct jargon. You see, I just commended Ashanti for speaking the mathematics. You
Yes,
said
sir.
to me 2 with the positive sign. There are two of them.
No,
Look here.
it's a superscript, sir.
So, but I
It's a
told them.
sus-
I told them.
All right, all right.
So that's what I'm saying to you now. Tell me at x equals -2 or x equals +2. So that's what I'm asking you.
Got you, sir.
Right. Right. So, but before you continue, Mason, let me just continue on that path. Students, I don't want you to think that I'm picking at you or I'm shaming you, or for want of a better term, I don't want to hear from you. That is not it. If you're not speaking the jargon in class, I am going to stop you. I don't care who you are. And I'm going to say that's not the way we speak it, because I want you to be able to. It's when you speak to something, it makes more sense to you and you can understand it better. So that's what sir is here for you to speak the jargon. So when you go and you talk maths, when you in your office and the man talk maths, and you can say, yo, no man, the left hand limit is equal to the right hand limit, so it's super continuous, man. The man say, blow, whoa, the man bright. All in know it, so he's speaking the jargon. All right. So please, I don't want anybody to take on offense. I don't care who you are. If you're not speaking the correct jargon, teacher is going to stop you. That is my function in the class as a teacher, not just to teach the maths. Teach you, and you have to talk it. Continue, Mason.
Yes, sir. So I'm looking at your workout for the -2 superscript negative.
Which are the conditions you're looking at? At x equals -2?
At x equal -2, sir.
Okay, good. So you're looking at this one here now, to the right of that. So you're looking at to the right of -2.
I did not do that one, sir.
Why?
Wait, sir. Why, sir? All right. Now I hear it clear, sir. Go again.
No, I'm saying, why didn't you do that?
Oh, no answer
Remember,
to that one, sir.
right,
Just never do that one day.
Coming to your Rayton. Remember now, if I want to investigate what is happening at x equals -2, remember, I must look at the left-hand side of -2 and I must look at the right-hand side of -2, don't it?
Correct, sir.
So I can't just look at one side. I can't just look at the left side. Over here is the left side. I can't just look at the left side and say, yo, it continues. I have to look at both sides of -2. Follow me?
Yes, sir.
So therefore, don't just do one. You can't do one and tell me say it's continuous or discontinuous, because you're not going to know.
But now I gotta get it. All right.
Right.
I'm only the half height, so I couldn't determine if it continuous or discontinuous.
Very good.
All right.
You sound like you catch it now.
You see my error, sir.
All right, big up yourself.
All right.
Rayton.
Yes, sir. I think I did something similar to Nigel, where I only did where x, I only used where was it? The function that says 3x plus 7, because I was looking at it from just my problem, or the problem I seem to have, is knowing which one of the functions to use. Because I was looking at...
Press pause. And it's for everybody else, because I suspect that is, if somebody not talking to me, I suspect what is the problem. And I never get a question right. When no one talks, I say negative, right? But you see, when I tell you put away all books and turn on all cameras, oh yeah, make sure that when I come home on a stage, go to here, because I would just come to class and say, turn on the cameras. I'm giving you a quiz, a pop quiz. I'm known for that. And all cameras must go on. And if the cameras can't go on, it means they can't do the quiz. So I'm telling you from now, giving you a little heads up, you need to get a device that have a working camera. All right? Because I can give you a pop quiz at any point in time. Hear me out now. Rayton just made mention of something. I'm going to just clear it up, because I know what the difficulty is. I'm the teacher. I'm doing this for quite a number of years. The problem is you guys are having a challenge reading the inequation signs and not being able to figure out and to associate what the left-hand side equals to and to associate what the right-hand side is equals to. So I'm going to do this one more time. Okay, so I'm taking my one little time. because it's when I say next topic. You see, like how Milton come, and some people get washed away. Those of you who are not grounded will be swept away with the wind and water too. So try and catch it. Here goes. It says determine if f of x is continuous. Write down the other part of the question, return, so you don't miss it. I just want to do this before I come back to you. Determine if f of x is continuous at x equals -2 and x equals +2. Given that f of x is equal to all of this. Now, when I'm checking for continuity, I must check the left-hand side, the right-hand side. I gave you the definition for continuity. The number 2 rule says you have to check the left, I have to check the right, and then when you substitute, you want to check the limit as x tends to a to the minus, the limit as x tends to a to positive, must be equal also to the limit as x tends to a. That's a condition for continuity, you know. So if the function is continuous, it means you have to look at the left, you have to look at the right, and when you substitute the value in there, as it were, you should get the same answer. So you're looking at a number. You're looking at a number. And you're going to be investigating the left of the number and the right of the number. If the left of the number gives you the same result as the right of the number, then the function is continuous. If the left of the number or the function or the number, better yet, gives you something different from the right or vice versa, the mere fact that they're not the same should trigger some sort of red flag. Put it this way, in layman's term, if they're not equal, it is discontinuous. If they're not equal, it is discontinuous. If it's equal, it's continuous. I have a question for you, Rayton, but I soon come. Let me just do this one. X is less than -2. When it is less than, Rayton, when it is less than, this is not a question incidentally. When it is less than, where do we go?
We go to the left, sir.
Very good. L for L. And how do you denote to the left?
Superscript minus.
Very good. So what is the problem?
All right, so I think what I did is, I don't know if you had said it or if I dreamt it up, but I looked at the formulas and I looked at which one met the condition x equal to -2. Okay.
Continue.
So I looked at x equal to -2. For the first one, x was less than -2. So wait, that one still, sir, I believe I'm very confused. Because I think what I was doing was putting x into the condition on the right, and if it did not meet the condition, then I would not have used that formula.
So who tell you to read like that, Rayton?
I don't know, sir. I may have dreamt it up.
Why would you be dreaming in a class? So let me go again. You need to investigate what is to the left and to the right of the function. So the question says to you, and for the rest of you in the class, question says, determine if f of x is continuous at x equals -2. That's the one we're looking at first. We're not concerned about x equals +2 just yet. We're investigating x equal -2 first. So that's what it is that we're investigating. We're investigating the function. We're investigating the limit of the function as it approaches -2. As it does so, we need to investigate what happens it approaching 2 from the left and what happens as it approaches 2 from the right. In other words, we're looking at the left-hand side and we're looking at the right-hand side of -2. Of the 3 equations, there is one equation on the board that deals with -2. Which equation on the board, or to the left, which equation on the board deals with the function -2 going to the left?
The first one, sir.
Yeah. So the first one you're going to investigate to the left. So We use the intuitive approach by looking to the left and right, and then we get also apply the calculations and method by just going ahead and just assuming that x is equal to -2. When I substitute x equals -2 into the function, 3 times -2 is -6, and -6 plus 1 is going to be equal to +1. So the limit of the function from the left-hand side is approaching 1. So Nigel, coming back to you, you can't tell me nothing. Because bird can't fly on one wing. So the bird not gonna move too far at all because you don't want something to do. I must now investigate what happens to the function from the right-hand side. Now, look at f of x and tell me which of the functions in f of x deals with the function as x tends to -2 going to the right-hand side.
The second one, sir.
The second one. And
I
now
think,
we're
I
going
think I
to
have it now.
right. And then now what we're going to be doing is assuming that x is equal to -2. So -2 squares is going to be a +4. And +4 minus 5 is a -1. Oopsie daisy. Them two something different. So it can't work. One is +1, one is -1. So Rayton, I'm going to ask you a question. Somebody gift you with $500 US. And you decide that you're going to sell me the $500 US. And both of us agreed on a rate. We agreed on a rate. You said, sir, I'm selling you this at this rate. And I also agree. But when you get the money is short. You don't make it slide?
Oh, no, sir.
No, we won't make it slide neither. So therefore, there is no continuity in the agreement that we have, don't?
No, sir.
Right. So there's some level of distrust, discontinuous, because you expect to get $150 for $1 US, but me pay you $140. There's no continuity there. The function will be continuous, the agreement will be continuous if we agree it's $150, but when I convert the $500 US, I convert it at $150 because that was our continuous agreement. You follow what I'm saying?
Yes, yes, sir.
All right, cool. Anybody else?
I have a final question. If you could just go back up to the question, just let me get some clarity on something. So for the first formula, x is looking to the left of -2, correct?
Yes, sir.
For the second, it's looking to the right of -2 and to the left of +2.
Yes,
and
sir.
for the third, it's looking to the right of +2.
You
Is
got
it
it.
that all the questions will have this same structure where you'll have the formulas? A formula should be there looking at both sides of the given number?
Yes, sir.
Okay, all right. Thanks, sir.
Please don't call back in them formulas. Here they are functions.
Functions.
Yeah, thank you. Justin, your turn.
So I'm just wondering if
I may not hear you.
so you hear me now?
A little better. Go.
So I was wondering if when you're writing the statements, if you write them separately or as one.
What statements you're talking about, Justin? This one here?
Yes, sir.
Come on, just write it just as I see right here. So this sign here, this equal sign with a stroke in between, means not equal to.
Yes, sir, I understand that, sir. Because you did the limits twice for one part. I was wondering if you just write the statements for each one, like at x equal -2, like write the statement for that and for the next one, or write both of them in one. That was what I was wondering.
You know, so I don't think what I said. I'm just gonna not lie to you.
So I think he's trying to say if I can put the statements at the end of at x equal -2 and at x equal positive 2, put both statements in one line after doing both.
After doing this?
After doing x at -2 and x at equal +2, put one statement at the end of those solutions and put them in one line.
So
put the
so
statement
so put
since
a,
limit.
so put a statement when I finish to this one, and then put a statement when finish to this one.
No, at the next one, x equal +2. Because remember that statements have to come at each one, you know, at x equal -2. When you do these two functions, then you do the next two functions, you have to have a statement at each, right? So after you're done with x equal -2, you put a statement at it saying it's continuous or discontinuous. Then when you do it with +2, you put another statement. He's probably asking if you put the two statements together at the end of each solution then.
Yeah, but I mean, I guess it really doesn't matter, but why move to another question? I don't finish the first question, because the first question asking, you know, is the function continuous at this? So I move over to this without finish answering this question. I don't know if you see where I'm going, Evan.
Yes, sir, I see where you're going.
Yeah, so just finish off one section first. So if you write both statements at the end, and I can see it, I don't think it really, I guess it's just cosmetic. You cook your dinner and you put vegetable to one side, or you mix up the vegetable in the food. It's still going same place, and when it reaches same place, it can look the same. But for me, presentation is always key. And this is how I present my work to you. But as long as it's, yeah, so finish off one section first. Was it Justin who asked the question? Finish off one section first, Justin, before you start answering another question, because lest you go forget to answer that part, because if you don't answer it, whether or not it's continuous or discontinuous, you're not going to get the mark there, you know. Even if I see this here and I know say it is discontinuous, you have to make the statement. And if I don't say the statement there, you're not going to get the mark.
Right, sir.
Go ahead, Kahim.
Sir, there was a question, a single one with x equals 3. I think you gave it for homework as well. I didn't see you go through it, and I wanted to check it.
Did we not do that in class last class though?
Sir.
You.
Yeah, why is it f of x and not g of x?
Sorry, hold on.
I guess it doesn't matter the name of the function.
But I'll come in like Harno. But Alwyn, sorry.
Oh,
yeah,
sorry
Alwyn.
about that, sir. I previous question I mean nothing. Oh, sorry about that. My mistake.
Oh, can you friend me a while ago? You friend me a while ago. So let me go back to based on what Lecarno says just now. His response to you. It's like how him name Lecarno and you name Alwyn, and I'm able to differentiate Lecarno from Alwyn. This is how the functions are differentiated. So I can use g of x, I can use f of x. You know, lots of teachers just stick with f of x, but I try and mix it up because I don't want you to think it's only f of x exists.
Yes,
f
sir.
Of x
no, because I think the question was stating g of x and
no man.
Yeah.
So me can't, if me see a road and call it Lecarno, you know answer me.
Right.
Good, because I'm not saying name. So me couldn't call this up as a g of x and then don't necessarily go call this f of x. And if you do that to me, make a mark it up because call your right name. All right. All right, good. Now, you notice how patiently I am taking your questions, because I'm going to be giving you one now. Maybe not right now, but in a few, that if you don't put that belt of truth around your waist, you are going to be swept away with this heavy showers from the hurricane. So let me ask the question again. I have responded to quite a bit of questions asked. Very good questions, and they would have cleared up, you know, some misconceptions. Going once. Are there any other questions? Going twice. Are there any other questions? And I'm not going to go 3 times. So I'm going to press pause And I'm gonna try and find me. Oh, who was it? Oh Lord. Somebody was asking about that the other question. Did I not do that question in class?
Sir, I don't remember because I thought it was for homework as well.
No, you need
Yes,
it.
sir. Yes, sir. I did it in class, sir.
Okay, could somebody just tell me the answer real quick?
No, you're too smart. You tell me the answer.
Sir, the same thing with. All
Me
right,
say you tell me the answer.
f of x is discontinuous at x equals 3.
Say what? No. Which question are you doing?
Sir, the same question for x is determine if x is continuous at 3.
Why is it discontinuous, Kahim?
Sir, because the left hand limit and the right hand limit were not equal.
Okay, so tell me, they're not equal, but they are what? What is it? The left hand limit is equal to what?
The left hand one was -3.
And
The right hand was 0.
good job, Papa. You did very well. Congrats. Big up yourself. Smart, but somebody tell me the answer. Go
Sir, but
away.
the same thing, sir. We didn't know the answer anyway, so.
Yeah. All right. Oh, okay.
Well, no,
So
sir.
no,
No,
no, no,
sir. I
no, 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 no,
answered it.
no, no,
I
no, no,
didn't
no,
know
no,
the
no,
answer. I
no,
answered
no,
it.
no,
I wasn't sure. I
Kahim,
wasn't sure.
no. I like your
Sir?
confidence. Nope. You have big talk. I like your confidence. Example 5, Kahim. I'm giving you 5 minutes to make sure that you do this one. The rest of you can do it, you know. And guess what? The rest of you want to flop him show here.
Sir, scroll back up to the first question where you work
Hey,
out
you.
there. Cool, no, sir. Let's get a quick screenshot now.
Which one that?
The first one you did a while
It's in
ago.
the
The
group.
first
It's in the
class.
group. It's in the group. It's in the group.
Oh, shoot, it's
It's,
in a
it's,
group.
it's in the group. It's in the group. All right.
No,
Thank
not
you.
a question. Not a question, Lecano. The solution.
Both the question and the answer is in the group.
All right. Thank you, sirs. Lefarno. Both of them in the group.
See.
Kahim.
Yes, sir.
No. I remember still here. Number 5 is still yearns. All right. You come with big talk. You better defend that. And guess what? The rest of you know, it's not me going to do it, you know. The rest of you, when Kahim does a question, the rest of you can say, yeah, man, Kahim, you're right. Big up yourself. Or nope, you're not correct. All right, come guys. I want you to try this one for me. It's really not difficult. I'm just trying to think outside of the box by just giving you different questions. I don't know what questions the exam going to give you. So I'm just trying to be very creative. I'm going to give you 5 minutes and then I'll come back to you.
So I'm done, sir.
Man, I move fast. Sounds good. Can you hear me? Can't make the people them finish before you.
Sir. Sir, what kind of question is?
What do you mean? What kind of question this?
Easy,
Hey, we're
but
gonna shake out to lunch man at time. We're gonna shake out to lunch man. Do the thing, man. It's doable. 3 more minutes.
Sir, I think I'm done.
All right, sounds good.
Okay, sir.
Good job, Logan. Good job, Andrew. Mr. Hamilton, sir,
Yes,
finish?
yes, sir.
Okay, what answer did you get for the, is it, yeah. What did you get at x equal 1?
Hold on. Sir, it's continuous at x equal 1.
Okay, how do you know?
Sir, because for the left hand limit and the right hand limit, they're both equal to 2.
Okay, very good. And I like how it is that you're explaining this. So I think you're understanding it a little better because your jargon, the use of the jargon is correct. Next, at x equal
And
2.
at x equal 2, the left hand limit is equal to 7, and the right hand limit is also equal to 7, which means the function is continuous at x equals 2.
All right, if you say so.
Bang answer, right.
Him sound right, Kenneth?
Yes, I'm right, man.
I don't think so, but
me just feel saying guess the first one though.
I don't think so. Nigel, you say, are you my call you know Nigel? But go ahead, Nigel.
Well, yeah, sure, Professor. All right.
That
So,
was one, right?
so
I'm getting your first answer.
you get continuous.
So the first x is equal to 1
Yeah.
is continuous.
Anything we get, sir?
That's what I got, yeah.
Yeah.
It is continuous.
Yeah.
No, that wrong box.
Sir, can we just get the answer? My anxiety is killing me.
All right. So hold on before you move on. So, sir.
Yes, please.
All right. So the first one where x is equal to 1, I'm gonna think I pick up that one there. So again, I work out half height. I'm gonna jump to the x equal 2. So I'm gonna work out both sides this time. I'm gonna get continuous at +7 left side, +7 right side.
Good job.
Where x is equal to 2. Yeah, that right.
All right, but that x equal 1 something there, sir. I'm gonna think me say the second part of what me for work out.
It is the same way work out at x equals 2, Mason. The same way work out at x. Same procedure. Same procedure, Mason.
I got a fraction at 3 marks, sir.
Me know.
No, man, another fraction because it say x. Hold on, sir. It say x equal 1, you know. But the equation shows x is less than 1. So it never say less than or equal to. So man, I look on it and I say, I can't.
But x equal 1 is just the number that is approaching. So you no need to look at the left of 1 and the right of 1. This is what I have been saying all along. I'm not saying anything different, Mason. So x equal 1 is what you're investigating. Now, because I'm investigating that, I must look to the left of 1 and the right of 1. So if you got the calculation correct for the point x equal 2, it's the same level of reasoning you're going to do for x equal 1. There's something that you're not seeing. Christian, I don't like why you're so silent though.
Sir, I just came home.
Okay, I cannot figure out the problem.
I'm working on it, but I found something interesting in x equal 1. It reminds me of the question that stopped me when we were merging into this subject. I forgot the word that we called it because of because of the denominator is 0 and it's a math error. It's
undefined.
Undefined. That's the word.
Yeah.
But But what you going to do? So I like the level of conversation
So because it's undefined, we're going to have to factorize.
very good, very good. Mason, I want you to listen in
So
Yes, sir.
because
man.
that was
Yes,
your
what have
problem,
you doing
Mason.
so far? That's been taking me so long. Is
Okay,
that
Christy,
to stop?
I love the sound of it, Chris. I love the sound of that. So yes, you're going to factorize. By what method though, Chrissy?
I'm going to factorize using, I could use substitution.
No, ma'am. Don't let me follow up anymore.
No,
You're going
don't,
so
because
well.
I'm not seeing any part where I can use.
You are going so well.
Oh, but
What
it's
is-
not 3. I'm
So it
stuck
is-
because I'm used to seeing
Hold
it
up,
in 3s.
hold up,
which is the-
hold up. So yes, and that is a problem
Yeah,
because
that's what I'm stumped.
you are accustomed to seeing 3 things. And that's exactly where I believe Mason is stuck at, because he's accustomed to be seeing 3 things to factorize. Know that you're not seeing 3 things. What method comes to mind? I'm asking you, Christian, what method comes to mind to factorize?
Then what else comes to mind is but not substitution. What do you call the thing where you look at what's common? Grouping.
So is it algebraic? Algebraic, that's what myself.
That's not what I'm looking for.
Difference of 2
When you
who said that?
I don't know that one.
Alwyn,
Alwyn, you have to teach that one.
Alwyn, me you go drink two Red Stripe Light.
Mr. Shan.
Yo.
The last teacher tell me say they don't give me it, you know.
All right then. I have to be careful of what I say then.
Yes, sir.
All right. Very nice. So it's going to be the difference of squares. See there? Difference of 2 squares. Mason, open your eyes and watch it, because I know this is where you had your problem.
I don't know this at all.
So it's a difference of squares.
But isn't that just like
It's just like the factorization.
Yeah.
But it's just that we don't have 3. You see, we normally have x squared plus something x minus 1. But we don't have the something inside of here. So watch me now, all of you. So you may ask the question, how do we recognize the difference of squares? Thanks for asking. As Chrissy says, she was expecting 3 terms. You now say 3 terms. You want to say 2. All right. The first term is a perfect square. Do you agree that x squared is a perfect square? Hello?
Yes, sir.
Good. Do you agree that 1 is a perfect square?
Yes, sir.
And it is separated by a negative sign. So once you have only 2 terms, that's condition number 1. The first term is a perfect square, condition number 2. The second term is a perfect square, condition number 3. And it is separated by a negative sign, condition number 4. It is a difference of squares. Justin.
Sorry, can you explain what is a perfect square, please?
What is a perfect square, guys? Justin is asking. I'm asking for a friend who is named Justin. What is a perfect square? I don't know what a perfect square is.
Sorry, it's the product of a whole number multiplied by itself.
Right. And I can have an algebraic term as well. So I can have x plus 1 times x plus 1. Justin, is going to be a perfect square. So 5 times 5 is 5 squares. A perfect square is going to be 25. Why? Because 25 times 5 is equals to 25. Or I can have x plus 5 times x plus 5. It's a perfect square because both terms are equal. The difference of squares, both terms, everything about it are the same, except that one sign is positive and the other sign is negative. And that's why they call it difference of squares. So it's not a perfect square, but it is also a square. But the signs are different in the middle. All right. Hamilton, big up yourself here, Papa. I'm happy that you are understanding.
Sir, I think I should take your
Say it again.
money instead.
I don't hear that. Say it again.
Sir, I'm saying I think I should take your lunch money instead.
Go away from here, boy. All right. Very nice. I'm happy that you are seeing that. Is there anyone else in the class that
Sir,
you know?
before you move on, break down the difference of 2 square. How is it that it's
Sir, I never see that coming, sir.
No, I don't understand how this concept of factorization works. Is the first, don't let me lie on my teachers, but
I was
it's
about
the
to say it
first
can't
I'm
be the
seeing
first
this.
because if you did foundation 1, 2, 3, you'd have seen it in 1, in 2, and in 3. And if you did CXC maths, you'd have seen it for 5 years. First form, second form, third form, fourth, and
I
fifth
have
form.
forgotten.
Okay. That I can
Some of
that
them
I
might
can
over
relate.
the kids
So
are going now,
remind
so
me.
just need a refresher.
Which year that, sir? Which year the matter come out, sir?
Which year the matter come out?
In a CXC, sir.
Go away, look, honey. So you're a young boy, so you're supposed to know this from the back of
Sir,
your mind.
sir, I never do CXC, sir. I left high school from 2015, sir.
Lecarno, I'm telling you, I'm teaching CXC maths for the last umpteen years, and it is there. But anyhow, you will see. The truth is, I'm not going to pause the class to just go through that piece now. But I will definitely try and get some stuff to you because really and truly, the difference of squares is a prerequisite knowledge. It's not on my syllabus to teach here. But it's a prerequisite knowledge. Case in point, I finally went through some stuff. And just to say, 1 or 2 or maybe 3 of you have not fulfilled the prerequisite for the course. And I had a conversation with Mrs. Campbell, and she has promised that she was going to be touching base with some of you. I hope she has. So I say this to say to you, Chrisann, that why we have prerequisites for the courses is that we expect you to have prior knowledge of an area before we get into another thing. But anyhow, that's just a little housekeeping aside. It's now 9 minutes past 6. I need to touch on this one now. I was about to say that I'm going to give you a 2 minutes water break, but I don't think I should give you the 2 minute water break yet. I think I should give you the water break when I finish this one because you're going to be needing it. It's not difficult. If you understand what it is that I just went through, you will see it. But I'm just going to ask for your patience and your attention. Your patience and your attention. Okay, let's go. I know it is so true. How I'm teaching this thing here is by doing a past paper. (2017) December says, a function f is defined as follows. Some of you still were in high school, but never mind. A function f is defined as follows. F of x is
You're
equal
sharing
to...
your screen, sir, or you're reading off something?
I'm sharing the screen now, but I'm going to share the screen to myself.
Oh,
I'm sharing it with everybody.
all right.
Tell me that you've seen it.
Yeah, and yes, sir. And there's a private message in the chat.
Oh, sorry. Thank you. Ah, yeah. All right. Yes. So f of x is equal to, again, we have three functions. Three functions. 2x squared minus 4x plus 2. Chrissy,
Yes, sir.
this is what you're talking about, the three something now, don't?
Yes, this we can do.
Right, right, right. Right. I know that's what you're talking about.
That's the regular formula for the factorization, and it's going to be equal to 0. That's the regular. You can use, substitute the A and the B, and you can follow the formula. But the other one wasn't picking up a bell.
Yeah, never mind. You were dozing off when teacher was doing that one, but never mind. I will give that a refresher. All right. So that part is fine, you know. Guess where the problem lies? We have AX plus B. AX plus B, hello? Sir, you never given one like that before? Yeah, you're right. You're only just now doing it. And then the other equation is 5x plus 7.
So that one I recognize, the AX plus B, when you go flip it to the other side.
Okay.
We're good
All
there,
right.
so 2.
Here what say now? Determine the values of A and B. Sir, you never asked if you tell nothing about if it continues or discontinuous. Sir, them man say, man, them start one way. This is what Mason been saying now. Sir, it started something one way and then after that, just flip it up and just, sir, I'm not even understanding something fully and then you're gonna move on to something else. Nope, it's the same thing. But we're now doing this in the reverse. So is you doing something from top to bottom and then doing it from bottom to top. It's just a reverse that you're doing. So if you understand the forward movement, the reverse movement should also be seamless. Remember, I need your undivided attention. Determine the values of A and B such that F is continuous over the interval negative infinity to positive infinity. Low. Are you seeing something, sir? But at this point in time, I just check to see if it continues from 1 something or 2 something. Like x equals -2 and x equals +2. The one you know, sir, look like it a say for every value, we want this function to be continuous. Yes, that's the question I thought about. So f of x is equal to 2x squared minus 4x plus 2 when x is less than -1. And f of x is equal to ax plus b when x is greater than or equals to -1 but less than +1. And f of x is equal to 5x minus 7 plus 7 when x is greater than or equal to +1. Ours is a task to find the value of A, to find the value of B, to make that something at work every single time. Do you agree in my solution when I say I'm going to start at x equal 1, -1?
Yes, sir.
How? Why? What two conditions are we looking at?
All right, so let me make a guess. The limit is approaching -1 and +1.
Very good, sir. Very nice. So that's why I'm starting at -1. That's why I'm starting at -1. Because of where the limit is going. Now, similar to what it is that we've done before, from the first night of class up to now, if we're investigating the limit as x tends to -1, we need to investigate what is happening. Do you agree with me that we need to look at the left and the right-hand side of the limit?
Yes, sir.
To the left of the limit, to the left of the limit, to the left of the limit here. When x is equal to -1, what is the function equal to?
Positive 8.
Are you
Sir,
trying to say
say
that?
that again?
I'm asking, when we're investigating to the left of -1, to the left of -1, what is the function equal to?
Positive 8.
Okay, I hear one answer, +8.
Is it 0, sir?
0, okay. By the way, how did you get 0 to the kernel?
After find out if it's indeterminate, sir.
When do we find out if something is indeterminate? When do we suspect that something is indeterminate, please, class?
After substitute the something, sir.
No, sir.
Substitute -1.
No, sir.
The denominator is a 0, sir.
Denominator
Oh, no, that's
zero.
fine.
No, sir.
So when it's undefined.
No, sir.
When it's 0 over 0, sir.
No, sir.
When x is approaching negative infinity or positive.
No, sir. When do we suspect that something could be indeterminate, class? When we have what?
When you have two of them not going into the same direction?
No, ma'am. Come again.
You mean like 0 over 0?
No, miss. Come again.
So when there's something
Sir, quadratic equation.
from reaching the limit.
The quadratic equation is not correct. Graduate, what were you saying?
And there's something in the function preventing it from reaching its limit.
No, sir.
So when the limits are not equal.
No, sir. I don't believe the class.
Sir, is it because of the x value and the whole number?
No, Logan. Anybody here? Anybody understand my question? And my question is prompted because of what the
Repeat your
said.
question.
It's again, sir.
Repeat the question.
My question is, Lacarna said something and it triggered off something. That's why I asked the question. The question is, when do you suspect the indeterminate form? What do you see that you could say this could be indeterminate? And what do you see that you notice not
Infinity?
No.
So the limit does not exist.
No. Come again. Not tonight. Come again.
Wait, sir.
So is it because of the x -1 in the denominator, you have the same -1, so you kind of cancel it out? Something like that?
So when the function is of a bad behavior.
No, Alwyn.
I think we're all saying the right answer-ish.
No, the only person that is about 25% right is Logan, and I'm not giving her any more indication.
Is it when you have to do more to the function?
Sir, you can
Get the
explain
right limits?
properly, sir. Is when the limit is x, going to the nearest -1, and when you're doing equation.
No, Logan, it gone off track. You were on your way.
I don't know what to say, sir. When x is close to -1 and the equation that is canceling -1 in the equation is blocking it.
I know what you're talking about in Logan, but that's not the answer I'm looking for.
No, but we don't know how to put
When the answer is not clear,
Say it again, Kaki.
So it's when the answer is not clear.
No, sir.
Sir, me that's it. When me make it say, when I cannot determine, when it cannot be determined.
No.
All right, Ella. Sir, talk up. Me not hear, sir. Talk up, man. Me not hear.
I'm lost. Feel like me not learn nothing.
Sir,
Yes, sir.
me not hear, sir. My answer incorrect.
Say your answer again, Kenneth.
I was saying that when it cannot be determined.
When can it not be determined, Kenneth?
Why?
So when x is the inverse of
That's
the constant
So is it because we have two infinities?
When the numerator equal to 0 in the function.
When the denominator x equals 0. Based on my notes here that you gave me, sir, I see we have 0 over 0, negative infinity over negative infinity, and we have positive infinity over positive infinity. But I'm
Okay,
not sure.
Okay, Ken. So since you're so persistent, sorry. Was that Andrew? Andrew, you just answered me. I said something a while ago.
Yes, sir.
You're about 25% right to Andrew. All right. So since you're so persistent, Kenneth, look to tell me from your notes how the
Yes, sir.
function looks when we're speaking about something that is indeterminate.
Go ahead, sir. I didn't hear you clearly.
How does a function look when we are referencing something that is indeterminate?
So when the limit exists.
Denominator and numerator, sir.
Thank you very much, Lacarno.
What's that, sir? What are you?
When I have a numerator and a denominator, that's the only time I can speak about a function that possible is going to be indeterminate. You cannot speak about indeterminate when you have a polynomial. Now watch me. So Lacarno said something and it, oopsie daisy, and it triggered off something to me. This is known as a polynomial. This is known as a polynomial.
There is no denominator.
Very good, Mason. There is no denominator. So here what is going to happen. This function is continuous every single time. This function, a polynomial, is continuous every single time. So is this one.
Alright, sir. Can you spell already if you reject the one, what's the please?
Which word?
Kali sitting down.
Poly.
Polynomial.
Poly.
Polynomial. Polynomial. So polynomial is a term with is a function with many terms. Poly means many. Right? So it's a function with many terms. So like this function here, it has 1, 2, 3 terms. So a polynomial is continuous at every point. Because remember, this continuity only occurs when the denominator equals to 0. Remember, somebody asked earlier in the class, what were they again? Christiana, it was undefined. The function is broken when a 0 exists in the denominator. So therefore, I can find that point of discontinuity, or the point where it is indeterminate, something down here is preventing the true limit from coming out. But I'm saying to you, at every single point of a polynomial, the function is going to be continuous there. Every single point, barring none. All right? So Lacarno, I stopped what I was doing because of what it is that you're saying. You're saying something about indeterminate. No. Indeterminate only occurs when you have a numerator and a denominator. Write that down for me, please. Indeterminate only occurs when there's a numerator and denominator. If you don't have a numerator, denominator, you can't talk about indeterminate. Learn that. Roger that. Cement that.
Yeah, so the same thing for the undefined, sir, where the denominator is 0.
Yes, Poppy. Yes, Poppy. Oh, yes, Poppy.
Sir, but I kind of forget the original question now.
Which original question?
Because he had asked what is happening to x. Ooh, x to the left.
No, man, that's not he didn't ask that. I was asking some questions, and then Lacarno says indeterminate. And then I stopped my lesson because I heard something that is not correct. So I needed to talk. And clearly Lacarna wasn't the only one, the whole lot. It took me about 10 minutes a while ago just to figure out what is happening. But I don't have a problem because at least you guys recognize what is happening now. When we speak about something that is indeterminate, and remember, no, it's not every function that has a numerator and denominator is indeterminate here. Some of them can be evaluated at the point. The indetermination comes when you have 0 over 0, or infinity over infinity, or negative infinity over negative infinity. All right, so let's continue. So now, yeah, man, trust me, man. I have to teach, you know. That them pay me for. I have to teach and make sure they catch it. All right, watch me now. So, yes, Alwyn, I remember you saying, I asked you at what point I'm looking at. And then he said to me, say, boy, sir, we are looking at x equal -1. Yeah, you're right. Let me ask another question. Which function in f of x deals with going to the left of -1? Sorry, no, don't answer. Don't answer. Nobody answer. Nobody answer. Mason, which function in f of x deals with going to the left of -1?
Me said the ax plus b, sir.
Okay. Justin, is he correct?
I don't think so, sir.
Why don't you think so, though?
Sir, because when you talk about going to the left, is a less than
But you
sign.
talk up, we can't hear no man. You keep secret, man. We not hear you. Very muffled.
Sorry, sir, the microphone. But I'm saying that when you're talking about less than, we're looking to use the So I'm losing my train of thought. So you can repeat the question.
No, man, continue, man. You're on the right, brethren. Relax yourself, man. You're on the right track. Continue.
So I was saying that when you're talking about going to the left, when you're talking about going to the left, we're looking to use the less than sign.
Thank you very much. Students, you know, some of them lack confidence. And I understand I can't do the work, you know. On a lack self-confidence.
So we can't run on strong, sir.
No, let me tell you something. Me want you to come strong to me in the class and make me pull you down and say, yo, that's not right. But you cannot be reserved and lack the confidence in the stuff. No. And guess what? It happens when you all go upon interview. Una the best person for the job, you know. But when I have conversation and nothing, I'm looking at the people, them, yeah, and I look down on the table and I talk to the people, them say, we're the plan, the man has the skill set, but we don't want him. You're the best person for the job. You might rather take on somebody else when not qualified as owner and train them because guess what? They're more outspoken and have the confidence. Come on, man. I want you to talk up in my class. Whether or not you're right or wrong, I'm the only one that can laugh at you. And I won't laugh. All right? But I'm saying I don't want you to be reserved. Sir, I don't know. And you're sitting on the answer. No, man. But that's very good, though, Justin. But yes, Nigel. There's only one function in f of x that deals with going to the left of the function. And it's going to be 2x squared minus 4x plus 2. How you know that, sir? Because the function says x is less than -1. So the conditions are very important, you know. So let me ask a question. Let me just not ask a question, but say something to you. Make a statement. If you go into the x, man, they give you a piecewise function, I'm not seeing these conditions there. The less than and the greater than something. The question here work?
No, sir, because it tells you which direction X is going to.
Straight up.
So I
If you
know
don't know
some
where to
misinterpret what you asked a while ago. But just said the X upon the next. All right. Pick up my error a while ago, sir. Why I say attack is that I look on my AX plus B. I'm say which part I went wrong in answering a while ago. So the X upon the other side are the lesser than sign.
Yeah, but remember,
compared
no, you
to
know.
the AX plus B answer what we gave a while ago.
Okay, fair enough. I won't deliberate on that. Okay, fair enough. All right, so yes. And then no, so we're going to investigate. And you're correct. I did ask, and you said to me that it is somebody said 8. Somebody had said 0, but somebody also had said 8. So to the left of it, we're going to substitute x equals 1. So 2 times negative 1. 2 times negative 1 squared, see to yourself, 2 times negative 1 squared minus 4 times negative 1 plus 2. Negative 1 squared is positive 1. Positive 1 times 2 is positive 2. And negative 4 times negative 1 is a positive 4. Positive 2 plus positive 4 is positive 6. And positive 6 plus positive 2 is going to be a positive 8. Other question to you. When does, in looking at your piecewise function and investigating, say for example, at x equals 1, when is the function continuous? Or how do you know that the function is continuous?
When the left one side and the right hand side is equal, sir.
Very good, Poppy. Very nice.
Okay.
Very nice, Lecarno. And this is what I want to happen now. Watch me. This is where the tire meets the road. Amanda, I'm watching you. I said I was going to say it, but I have to say it. You have never unmuted to speak to me in class. And that's not good. Lecarno, that's very nice. This first piece here is what you already know. This is a piece that you don't know yet, so I want you to pay attention to this. In order for the function to be continuous at x equals negative 1, both of them supposed to be approaching 8. The limit to the left of 1 and the limit to the right of negative 1 supposed to be equals to 8. Do you agree with that?
Yes, sir.
Good. So I'm doing the same thing as I have done before in the first one. Anywhere in the function I see x, I'm going to substitute negative 1. So this is going to be a times negative 1. See to yourself? A times negative 1 plus b. I'm going to have no more x to substitute, so I'm going to leave it like that. What is negative 1 times a? It's a negative a.
Negative.
Plus b equals 8. So the second thing, it's supposed to be negative a plus b equals 8. And once them two something here can be achieved, then you can say the function is going to be continuous. Yes, Nigel.
So I think we miss it still, but how you get x to approach negative 1 based on the question?
Because we're investigating to the left of negative 1. You recognize, what two numbers are we investigating, Nigel?
Negative 1 and positive 1.
Very good, son. Excellent. So negative 1 and positive 1. So we're investigating to the left and right of negative 1. You just told me a while ago when you corrected yourself that we're looking at the left and right, and that the left of negative 1 is this function, and the right of negative 1 is this function. The left of positive 1 is this function, and the right of positive 1 is this function.
Also 5x.
All right?
Yes, sir.
Let me press
So-
pause and just go ahead. Somebody's coming in?
Yes.
Yes, Logan. Go ahead, Logan.
My confusion is that for like a equation that's similar to this, and they're doing ax plus b, plug in the negative 1. Is it always going to be equal to the one that you already done up the top?
Very good, Logan. That's a very good observation, and my response to you is yes.
Oh, okay. Because I
Yeah,
didn't know if negative a plus b should equal to 8, so that was confusing.
Yeah.
Sir,
Sir,
I had a question, but I think it's the same as hers. Was she asking about the values of A and B?
She's asking what it is equal to.
Oh. Sir, you said that polynomials are always continuous, right? So based on that, you would know that ax plus b is also
continuous.
Right. Thank you, Reggie. That's what I was going to ask. What's the logic behind it? That explains my question.
Just one thing I will correct in the statement though, Roger, is the limit of a polynomial is always continuous.
Right. Yes.
Yeah. You know, something came to mind and I'm going to share it. But in sharing, I'm going to ask you a question. I'm just going to see how well you guys, you know, are aware. Name me, if you know, you may not know it. A major supplier of ceramic tiles to Jamaica. Which country?
China.
Say it again, Justin.
China.
China. Okay. Anybody else? I'm going somewhere. Just quick and answer so I can
Don't know it,
go there.
sir. Don't know it.
You don't know it. All right. So Brazil is one of the most of the tiles that I see in Jamaica are coming out of Brazil. And I know you guys have this experience. You may work in an organization that has beautiful tiles, you know, that are laid. What if one of the tiles is broken? What the man them do?
We cover everything.
Them take out them take out everything? Them retile the whole place?
Them take out the broken tile.
And do what?
And leave the foundation and then put back a new tile
Okay.
or paste it back on.
Sir, sometimes they dig up the tile.
Then have to dig up back the original
sometimes they cover
structure
them.
there, sir.
And do what with it?
To make back a foundation for lay the new tile, the replacement.
Right. And sometimes when them do that, when them do, if them creative and just make okay, let me ask you a question. Can they go back and buy back that exact tile to put down?
Rarely, sir.
It depends.
Sorry, Rachel, what did you say about it?
Said rarely. Most times
Okay,
when
you know why I wouldn't use the word really? Because when the tiles are made, the mold is gone. So they don't necessarily keep the mold after making the tiles. Okay, sir. I think I follow that. This is what we're talking about. I can give them multiple piecewise functions. Each piecewise function gives a different design on the tiles. Each piecewise function give a different design on the tiles. All right. So, and how the design come in? Is it a continuous shape or a discontinuous shape? I'm just going to see if I can find, and this is going to be important, you know, because you notice I don't do any graphs with you yet. Because I want to make sure that you understand what is happening here. Yeah. I'm trying to find something just to show you. Come on, Sir Shand. Why are you not seeing it? All right, I'm going to. All right. What I'm going to do is I'm going to finish this question, but please remind me. I just brought up a graphing tool that I'm going to be sharing with you. I mean, I have it in mind to share it with you, but it's just that I'm going to share it earlier than I expected. And then I'm gonna tie in what it is that we're doing here with the piecewise function and how we use it, how it is used in real life. Right? the man them I use the maths and I make more money off it than me and you. So just remind me after this example here. All right, let's go back to this now. So I am going to press pause at x equals at this piece here. I can't go any further. Why? Because I have two unknowns in one equation. I can't solve an equation with two unknowns. All right. So I have to look at that. All right. I'm gonna step away for 2 seconds, but I'm gonna also project. I'm also going to be projecting at x equals 1. At x equals 1, remember now, at x equals 1, we have, let me reduce it so you can see the function. At x equals 1, you don't need to see 2007. At x equals 1, to the left of 1 is going to be ax plus b, and to the right of 1 is going to be 5x plus 7. Look at these, look at them both, and tell me if you see what is happening. Give me 2 seconds, I'll soon come back. How we stay?
Multiple questions.
Go ahead.
With the questions. So I was looking at it from top to bottom. My first question is, how can one function be equal to 2 different things? And then when I saw you starting the solving of the function, how is it that it's negative? So at first I was thinking maybe it's because of what it's approaching, if it's to the right or to the left. But then I'm also realizing that in when it's x is equal to -1, it's approaching to the right. However, at x equal 1, +1, it is approaching to the left. So I couldn't, in my mind, figure out how to start, because my way of looking at it will be, all right, ooh, I see it now, right here. But then how is it -a? So yeah, lots of questions.
Can somebody tell Christian where the negative come
All
from?
right, sir.
I think I'll need you
let
to
me look on it.
explain.
When me look on
when
it, sir.
From the
Me look on it, sir. As we say, polynomial always continuous. So the unknown are equal to the polynomial. So from the negative a now would be the function from the left side. The positive one would be from the right side. As we have the x tends, the limit tends to subscript negative. So that's right.
You hear
So
Christian?
so it starts from right here where it says a bracket -1. It's taking on the characteristics of -1.
No, it is coming from the
Maybe I'm
left.
lost.
Nobody can't, it can't be lost.
Coming from the left.
It's the same thing that we've been doing. The superscript is telling you what direction we're looking at. So
Mhm.
again, we're looking at x equals 1.
Mhm.
And because we're at x equals 1, we need to look to the left of 1 and to the right of 1.
Mhm.
The right of 1 is going to have the superscript plus, and the left of 1 is going to have the superscript minus.
Mhm. Mm.
So, sir,
So
question then
what
to
at
Chris, the
all?
Christian question. Probably she will understand a bit because I'm understanding. Is it a case where at x equal -1 is approaches from the left, that's why it becomes negative a, and then because it's x to the 1 now, it's the positive that would go to the right, so it's a positive a.
No. Hold on, Evan. Hold on. Please do not look at this negative a plus b and confuse yourself.
Yeah, man, I'm disregarding that now based on what's happening with where it's
Right.
approaching, but
So all
that
you're
just
doing
made
is
me
looking at the function, whether or not it's going from the right to the left, whatever it works out to be, that's fine.
So that's
Whatever
how
it
we
works.
got both of them.
Yeah.
Okay, now understand. So we're looking at it from its approaching the left and the okay, understand now. So automatically
Yeah, and whatever
it's
comes
going
out
to
just
be
comes out.
negative.
Yeah, man.
Okay, good.
So
I was looking at this too much, the x, and then I disregard it when it said looking at where it's approaching. No, understand. No,
Yeah,
understand
man.
where the negative comes from.
Yeah. So when I look at my function here, this one is going to go to the right of +1. So to the right of +1, it's going to be 5 times 1 is 5 plus 7 is 12. That means the limit is going to 12. That means to the left of +1, in order for the function to be continuous, it has to also be going to 12 or equal to 12. And that's why when I substitute a times 1 plus b, it has to be equal to 12. See here? A times 1 plus b must be equal to 12. And then all we do is to solve these two equations simultaneously.
But so, sir,
I
it's the same
believe
thing
that
for the first one.
Go ahead, Kahim.
Sir, it's the same thing for the first one for 8.
Mm-hmm.
But sir,
So I
how do
was
you
saying
know that it's
continue.
how do you know that 8 would be equal to 8?
May I, sir? May I jump in now?
Oh,
Go
because
ahead.
it's continuous.
Duh. Yes, Kahim. Duh. It is continuous.
So
It has to be
all of
equal.
it, and that's from in the question. We know that it's
Yes.
continuous. So whatever the -1, whatever the part that we know, and we can work out whatever it is equal to, we know that the other part of it will certainly be equal to the same number.
Tell them why, Tajay. Because
it is continuous,
it is
and both left and
continuous.
right has
Yes.
to have the same value for it to, in order for it to be continuous.
Yes. That's all I've been saying. I've been saying that from the start of the question. Yes. It must be equal because you are trying to determine the values of A and B such that f is continuous over the interval. You see the interval? -infinity to +infinity. The whole interval we want it to be continuous for. So we need to find the values of A and B that will make that happen. So that's why them two must be equal. And that's why them two must be equal. And then now, because we know that this is 8 and this is 8, we're trying to find the value of A and B. So therefore, we're going to put -a plus b equals 8. See it right here, so call it equation 1. And we're going to put +a plus b equals 12. See it right here, so call it equation 2. And we solve those simultaneously. Now, let me make a statement, please. I am not here to teach you simultaneous equations. Simultaneous equations is a prerequisite knowledge for this course. I am not here to teach you simultaneous equations. Simultaneous equations is a prerequisite knowledge for this course. So what I'm saying to you is that you must know how to solve your pair of linear equations simultaneously. With that said, I shall do this once as a refresher So we're going to be using the elimination method. And why the elimination method? Because I recognize that the coefficient of the variable A are the same and opposite. What do you mean by coefficient, sir? The number in front of A is the coefficient of A. What number is in front of A for equation 1, please?
Minus
One.
one.
Negative one.
Good job. Good job. And what number is in front of B? A in the second one.
One. Positive one.
Positive one. Very nice. Very nice. Very nice. So therefore, I'm going to be adding both equations. And when I add both equations, you'll recognize that negative A will cancel out with positive A. Those two go to 0. So that's why we talk about the elimination method, because I'm eliminating one of the variables to work out the other variable. I'm eliminating one of the variables and then back work it to get the other variable. And B plus B is going to be equal to 2B. That's all is 2B. And A plus 12 is equal to 20. In order to determine the value of B, I'm going to divide both sides by 2. So I'm going to have 2B over B over 2 is B. And 20 over 2 is 10. So B is going to be equal to 10. Anywhere in the function I see X or A or B, rather, I'm going to be substituting the value of B in order to work out the corresponding value of A. So I'm using this equation, A plus B equals 12, equation number 2. So anywhere in equation number 2, I see B, I'm going to put 10. So I'm substituting B for 10. Because I'm working the question simultaneously, the word simultaneous means at the same time. So therefore, A plus 10 is equal to 12. I'm subtracting 10 from both sides. A is going to be equal to 2. So I'm saying to you, in order for that to work, the value of A must be equal to 2, and the value of B must be equal to 10 for this here function to be continuous every single time. All right. Let me just press pause and then you share and I'll show you something. All right, so I'm going to introduce it to an open source called Desmos Graph. This is what now? 2x squared. Anybody remember the function? 2x squared.
2x squared minus
2x
4x
squared minus 4x plus
2.
That's what? Plus
plus
2?
2. Yeah.
And then we had ax plus b down, and a was 2, right? So it's 2x plus, what was b again, 10?
Yes.
Yeah.
Sir.
And then the other one was what? The last equation was what? Anybody remember? All right, let me go back and
5x
look.
plus 7.
5x plus 7?
Yes, sir.
All right. Oh, come on. That's not where I want to go. Sure. All right, so that's my graph. And I need to be able to sketch what the graph is. I need to be able to sketch what the graph is, to show you the region. This was X is less than what again? -1?
Yes, sir.
Uh-oh, we're gone. Yeah, the function gone.
It just gone, probably some
Yeah,
function.
it just disappeared. Anyhow, what was the other one? That one is
-1 less than or equal to x less than 1. No, sir, change the sign of before 1 to less than 1. Not less than equal to, but less than 1.
oh, less than, just less than. Okay.
Yes, sir.
And this one was greater than 1 or greater than equal to?
X greater than equal 1.
All right. All right. I don't know where my graph gone.
Sir, hold on. The first one you only had less than -1. Is it a case where you needed the x less than -1? Or the x isn't there? I wonder if that affects it. Right
No,
after
no, not really.
Semicolon affect it, sir.
The semicolon shouldn't. All right. I'm looking for my piecewise graph. This is a good introduction to. I may not seen a piecewise. I'm not seeing piecewise here. Right. Oh, I don't need to sign up. I need to just sign in. Okay, so I'm into my account. Why am I not seeing? Okay, something is not looking right. What? Okay, that calculus 2, January 28, calculus 2. This is strange. I am not seeing my. All right, I need to. All right, I'm gonna come back to that one, but I'm just gonna finish my conversation. Read those tiles. It's supposed to be here though, and I've used it before, so I don't know why I'm not seeing. And I'm into my account, so what is up? All right, I'll look back at that for next class. Let me just show you something for argument's sake. All right, let's just look at the polar rows. Are you still seeing the graph, or are you seeing it, the graph? Or I need to do a new share.
Yes, sir.
Yes, sir.
Okay. Now, anybody ever see tiles will look like this before? I mean, like designs with them something, maybe not the exact thing, but
Yeah,
Yes,
yes,
sir.
sir. Yes, sir.
Yes, sir.
This is where it comes from here. And if I do this, it gives me many different shapes and designs. So these are what I call polar graphs. And I can also do this stuff And so this is why sometimes when I do the graphs, and this is math, incidentally. You know, when you're doing your polar coordinates, I'm in deposit and get a nice little design. The man they may say, look at that design. The man them say, okay, this is the design we're going to be using. They have the formulation in the system, and the tiles make the stuff. So something like this now will be continuous. Because if I were to start here, you recognize that I can go here and go around without lifting my implement. You recognize I can make this loop. I may go around the value, the point more than once, but you recognize I don't lift my implement. If I start here, I can go here, I can cross over, I can go here, I can come back here, go around here, come here, go under here, come here, I can go on the outside without lifting my implement. Anybody can see that?
Yes, sir.
Yes, sir.
Yeah, man. So in a case like this, this would be a continuous function, right? I'm a little concerned with that. I'm not seeing why I'm not seeing the my other stuff, but anyhow, I will sort it out. Yeah. So that's just one thing that we can show you. I can look at, well, this is not on, this is like a time series with different things taking place on a graph itself, in and of itself. And if I animate, it also gives you, so these are things that you are going to be learning down here, so in the second semester. And if I remember when I'm doing it, I'll come back and show you how to do these calculations. We're not doing any of the trigonometric ratios, but things like these in terms of doing Maclaurin's expansion is what it is that we're going to be doing in order to get functions looking like these, right? If plotted, we can get things like that. So I say this to say to you that most of the things that you see out there in terms of designs, oftentimes are trial and error regarding your graphs that you plot. Let me see if this parabola can see that parabola can. I still don't understand. I can't find my something. You know?
You pass a parabola, sir.
Yeah, man. I know I pass a parabola, but I was looking again to see if I can find my
Piecewise.
my piecewise, but I don't. All right. So if I look at my parabola, let me just play it and show what is happening. So you see, it gets closer and closer to the y-axis, and it gets all the way down until it flips and go around. It flipping and go around, going around. It is accessing or pivoting on this blue line. All right. And this is when, so this is what I was saying to you, if I were to put my function like this, similar to the piece like that we just did, that's what will happen. So if I allow B to go, B is going to be my straight line. If I allow C to go, then all of that takes place, right? I'm going to stop these two. I'm going to stop that one. And I'm going to let that go around and stop it when it gets to, all right, I'm stopping it there. Now, I want to highlight something to you. Now, I can use this parabola. And if you come from America, you will say parabola. A little later on in, is it this course or next course? Is it calculus 1, calculus 2? Let me see now. In calculus 1, we're going to be calculating the area on the curves, the area under the curve. And in calculus 2, we're going to calculate the volume generated when things like these rotate. So if I want, I can cut this off right here, so, and I can rotate this, and I can get a basin, or I can get a cone, or I can get something else. We call it a fruit bowl, right? So I have to go do those calculations in calculus class here. Yeah, man, I won't ask you to do no rotation, to sketch the rotation of the stuff, but for sure, I'm going to ask you to calculate the volume generated when something is rotated either 360, or it's rotated 180, or it's rotated 90 degrees. All right. So I say all of this to say to you that lots of times when you see these shapes are often geometric. Whenever you go to the hardware store again, just look at those tiles and see, and you can see the geometry that comes out in those tiles. And when you see the geometry, it is things like these that they use to make these tiles. And they use the one formula, they don't necessarily store it because they have multiple formulas, an infinite number of formulas that they have. So they don't need to store it. So which is why when, if you're tiling your home, and you are supposed to be using 48 tiles, if you can buy 50 tiles or 60 tiles, buy it and put on the rest of them, because if something goes wrong, you're plumbing something not working, and it's mathematics, you know, real maths. You're plumbing something not working, and the the plumber say, yo, you know, I have to take out this because this don't work, and him lick out the tile. At least you'll have extra tiles that you can use. If not, you have to be very creative and to get a design. What it is that we're doing here, I can get my piecewise functions to give me my graphs. Let me just show you, since I'm here, new blank graph. Let me just show you what is happening here. The function, go again for me, please. 2x squared. 2x squared what? Minus 4x?
Yes, sir.
Uh-huh.
Plus 2.
Okay. Plus 2. No?
Yes, sir.
It's plus 2?
Yes, sir.
And what was that? That was less than?
Less than -1.
Less than -1. All right. Now, all right, I don't think it's going to work if I don't have the all right. All right, let me see if I can do the all right, let me just see if I can read inchwise. No. All right. So watch me. Can you see that -1 is right here?
Yes, sir.
Yes, we can.
What? So watch this line. Watch that line. Watch that line. So if I pass right here, so I'm gonna go over more than less than -1, don't?
Yes, you would.
Yes,
All
sir.
right, good. So what the function is saying is that x is less than -1. So it means then that this part of the graph, if I were to shade what it is that I want, this graph is saying, this function rather, based on the condition that x is less than -1, is suggesting that all I need are values over here. So, and I can't write on this enough. I'm going to need values over this side, Because anything even inside here says greater than -1, don't it?
Yes, it is, sir.
Right. So based on the graph here, if I were to, and you are required to plot, to sketch, not plot, but to sketch these graphs. So if I were to look at this, I'll be sketching the area over this side. But there's another condition to say ax plus b. A was it 2? 2x plus 10. There's another condition, and what was that? That one was x is greater than -1 but less than 1, don't? X is greater than -1. The condition that, can I just minimize this because it's too big for the screen? X is greater than -1, but x is also less than +1. So x is greater than -1. Greater than -1 is everything going this size, don't?
Yes, sir.
But it says it's less than +1. That means it can't go over here, so?
No, it can't
No,
pass
sir.
+1,
Good.
sir.
Very, very nice. I'm happy that you guys are seeing that. So technically, the condition for the second equation is saying that x lies between -1 and +1, don't?
Yes, sir.
Good. So the values of x, then just watch it because I have to go up on the graph. This is a very big graph. When I start sketching using my writing tablet, you'll see it a little better. I think Rayton asked a question that caused me to just jump over here. So so my value is going to be -1, +1. So let me go up to the graph. So based on what is happening, it is saying that I need the values only between here and here. Need the values between there and there. So these two functions is saying to me now that this function says to me that I need the values that is greater than that is less than -1, which will be the values not here, so, because anything under here so is going to be less than greater than -1, don't it? Because if this is -1, that means everything going this side is going to be greater than -1, don't?
Yes, sir.
Yes, sir. Correct, sir.
So the graph, as I was saying to you when I did the first graph, that I am only concerned with the values of this graph going up right here. Then this blue graph come in and cut it off now to say, yo, right is right here. So this point here, which is a -1, to the point here I'm interested in. So technically, I'm interested in all of the areas inside of this. I won't call it V, but I could call it a V. So everything inside of this area here, I'm going to be interested in for now. What was the other equation? Anybody remember the last part?
I believe it's
5x plus 7.
5x plus 7, 5x plus
Yeah.
7. And that was what? No, greater than 1.
Or equal to, sir.
Greater than or equal
X
to
is
1.
greater than or equal to 1.
So we know that this is 1. Right? We know that this is 1. So what this is saying here now is when I plot my graph, this point was less than 1. I'm going to have an open circle right here. You may not be following this just now because of how it's being plotted on this stuff. But you're going to have an open circle right here. Why are we going to have an open circle here? Because it is only less than 1. Value is only less than 1. Let me show you what I'm talking about. No share. Where am I? This is only less than 1. So because it's less than 1, it's going to be an open circle. You see the other piece here that says x is greater than or equals to 1? Because it is greater than or equals to also, it's going to have a shaded, a solid circle. Now, because this one is a solid circle, it supersedes this one. So at the point here, I'm going to have a solid circle to show you what is happening. So this function is going to be continuous at this point because of the solid circle that is here. Let me go and show you something here now. This one says x is less than 1. But the mere fact that it is less than 1, it says that it's going to be a hollow circle. It's going to be open. Now, if it is open, it's going to be discontinuous. But at the other end, this one said that x is greater than or equals to 1. So because this one is going to be closed and they share the same point, it means therefore that it's going to be a solid circle. X equals 1. X equals 1. Right here, so. So here it says it's going to be a solid circle. So this shape is going to be, that shape is going to be, oh, come on. All right, let me see if I can reduce it. So that shape is going to be something that comes here. It comes around here. It stops right here. No, yeah, it stops right here. So it's going to come here. It's a funny shape. It's going to come here. It's going to come all the way up here. And it's going to stop right here. This blue graph cuts off the rest of the graph up top up here. So if you don't understand, if you're not following, I can understand because it may be a little tricky for you. Anybody seen what I'm talking about though?
Yeah, a little bit. Bits and pieces, sir.
Yeah, man, bits and pieces, right? So what I'm saying to you is, so you have your 3 functions. You have your 3 functions. The first function is a quadratic, and the quadratic graph is going to be this one here, the one that is in red. Let me show you. The one that is in red. See the squared one here? So this is going to be your quadratic graph. So you're going to have that basic shape. And for those of you who did Foundation Concept 3 with me, I did allude to when you're doing Foundation Concept 3 that when we get to this part of it, you're going to see the curve sketching coming up even more. So this is going to be your basic shape of your piecewise. Then 2x plus 1 is going to be a linear graph, a straight line graph. And that's blue. And it tells us about it lies between here and here. 1, 2. Sorry, I have to show where the 1 is. It lies between 1 and -1. It lies between this one here, this +1, and this -1. So what I'm interested in is in between right here, these 2 points. And then x plus 7 is greater than, is greater than or equals to 1. The one in green. So it is saying that the other part of the graph is going to go all the way up here. All right, let me see if I can look back at a simpler graph that we did the last time and see if I can show you what it looks like. Because I want to give you one of these to do, you know what? All right, exactly. I'm going to do the graph manually, and then from the manual graph, I'm going to go back to the Desmos. But Desmos is something that I want you guys to play around with so that you can see things that are happening with it. So it's desmos.com. It's an open source. There's a paid version one, but you don't have to pay for it. I mean, the open source version works perfectly fine. So you can play around with it. What I want you to do for me is, I want to give you one of these to do on your own. I mean, I'll be here to guide you, but I want you to try something. This is not a bad one. This one is easy. This one is easy. I think we should do this one. I think we should do this one. This is also a past paper question. Guys, we're at the stage of our teaching and learning where past papers are very important, and I'll be using lots of past papers in the class. Thanks again for those past papers, guys. I've gone through past papers and I've extracted these questions and I've worked the questions, and then I'll take them to class. I won't work all the questions, but I'll take them to class. I want you to look at this function. Again, this one is a piecewise. It has 3 functions as the one before, but the functions you can see are simpler. The question says find the constants a and b so that the function is continuous on the entire real line. Now, the entire real line is the same thing as me saying between negative infinity and positive infinity. Can you appreciate that?
Yes, sir.
So what it is saying to you is everywhere, every and anywhere, we want the value of a and b so that this function is going to be continuous. Is that understood by everybody?
Yes, sir.
All right. I want you to give this one a try. I don't know how we're going to do it. Let's kind of, did you screenshot the other question that you could drop in the group? Let me minimize this so that at least you can. Okay, that's ridiculously small. Fine. Can you get that?
Right click on home, sir, and make it automatically collapse the ribbon.
Right click on home.
Yeah. Collapse ribbon. I think that should defend it a little bit more. But somebody say, zoom it up one more time, sir. Control plus.
All right, so I think that's the best we can get it. So you could just screenshot this and drop it in the group for me, please, which is technically what it is that we're working in class tonight. So I may not necessarily send you again something again, Lacarno, to post for me. And then I am going to let me know when you finish with that, Lacarno, so I can.
Fair enough poses, sir.
All right, thank you, sir. And then now what I want to do is now give you this question to work. If it means that you're going to go back and look back, go and look back at the one that was just placed in your WhatsApp group, I would encourage you to do that, but I also want you to be able to get an opportunity to do something right here. All right, I give you 5 minutes to start. Make sure you guys are not sleeping in when you're working on a paper, on a question, please. Obviously.
Good night.
Oh, 131. One at 130.5. Always stay.
Sir, we can get 5 more minutes.
5 more minutes.
Or 3, sir.
All right, do it.
Yes, sir.
What was that, Logan?
Said that I'm finished.
Are you finished? Okay. Drop your answer here in the chat, privately or otherwise, and then let me. All right. So just drop some more answers here because I'm seeing one or two and I don't like how them look. I want to see if somebody, the first person to get the correct answer, I'll just start sharing. We have a couple minutes left. All right. Pick up yourself because you have improved.
I send mine, sir.
All right. There's some of you in the class that are following. Well, that are understanding because I'm getting the correct answers. Some of you are a little off, but yeah. So all those private messages, just check it in comment, please. I respond back. I responded to you privately. And in another minute or two, I'm expecting to see some more responses, and then I can just go through those with you. All right. Sorry, I'm still responding. All right. All right. No, one of the things I'm going to ask you guys not to do ever do in my class, you see? One of the things that I personally don't like, and I'm going to ask you not to do it, is to give up on yourself first and then give up on me after. If I tell you, if I do the question 100 times, you can do it. There's a reason I asked you to do it 100 times. Don't give up on yourself. All right? Some of you got it right. Some of you, I believe the science is the problem. Let's go through the question quickly. It says find the constants a and b so that the function is continuous on the entire real line. And it gave you f of x is equal to 2, such that x is less than or equal to -1. And ax plus b rather, is such that x is greater than or equal to -1 but less than 3. And at -2, x is greater than or equal to 3. What do you know about finding the limit of a constant?
It's the constant, sir.
It is a constant itself. The limit of a constant is the constant itself. So that's the first thing that you need to remember. So look at what I have right here. Look at what I have right here. The limit as x tends to -1 to the left, which is this one here, of 2, is going to be equal to 2. Why? The limit of a constant is the constant itself every single time. And then no, because it is supposed to be continuous on the entire real line, as Tajay said, right? It means that whatever works out right here when I substitute -1 into this function, which is x going to the right, it must be equals to 2 in order for the function to be continuous. So I'm going to say, I'm going to look to the right of -1. So it's going to be a times -1 plus b, which is a -a plus b, and it's going to be equals to 2. Oh, sir, every time I do the question, I'm going to get a -a plus b? No, it just so happens that this one worked out almost to be the same, -a plus b, right? I don't want you guys, when I teach you, to be that stereotype either, all right? And then no, we'll finish the first one. Sir, why are they supposed to be equal to 2 again? Because it's supposed to be continuous on the entire real line. Supposed to be continuous. So it has to be equal. All right, so I think I get that. And then I need to try the other one. But sir, hold on, man. See, you have another constant down here, so don't worry about it. The limit of a constant is the constant itself, not change. The limit of a constant is a constant itself. So what is going to happen is this -2 to the right of 3 is still going to be -2. See it here? The -2 to the right of 3 is -2. The limit of a constant is a constant itself. To the left of 3 is going to be ax plus b. How you know, sir? See it here? X is less than 3. So a times 3 plus b must be equal to -2. A times 3 plus b must be equal to -2. Why, sir? Because if it is continuous over the real value, the entire real line, it simply means that it's supposed to also be equal to -2. And then I'm going to solve these two equations simultaneously. -a plus b equals 2, and 3a plus b equals -2. When I do this, what I did for my solution, it don't have to be the same thing, is that I multiply equation 1 by 3. So that is going to give me -3a plus 3b equals 6. And I call that equation 3. Equation 2 remains the same. And then I'm going to add both equations. So why are you adding? I added because I recognize the signs are opposite, so they will cancel out after rationalizing the functions, the equations. And then now I'm going to add 3a plus b to give me 4b. I'm going to add 6 to negative 2. I'm going to get 4. And of course, we divide both sides by 4. And I'm going to get 1. B to be equals to 1. Always substitute the value of b into one of the equations. I chose equation 2. Anywhere in equation 2 I see b, I'm
Sir,
going to
sorry
put
to
1.
interrupt. I do apologize later, but could you scroll back up a little bit back to where you did the multiplication of three equation 1 by 3? Okay, just 2 seconds.
No problem. You want me to go through it or you just want to look at it?
So I'd love it. Sorry.
If that's your way you go through it, you can go through it. I just need.
No, I see it. That's where I was a little bit stuck, truth be told, because I got to where you have method 1, eliminating the A's. I'm thinking to myself, okay, what do I then do? So I didn't continue from there.
But you had those 2 equations, right, Taj?
Definitely, yes, I do.
Great.
Yeah,
So what that
also
is saying to me, what? Sorry, Rajay. Say it again, Rajay.
Yeah, I was just saying that I was also stuck on the method of simultaneous
Okay.
equation.
All right. So for the pair of you, Rajay and Tajay, Rajay, Tajay, for the pair of you, I would suggest that you just do a quick refresher. I know you guys are smart, you know. Just do a quick refresher on simultaneous. I know it's been a while since you've
Right. I think that's where the issue is really.
Right. So if you do that, I'm sure by next class you're going to be very sharp. So I'm not too concerned about it, but tell me that I can move on and just finish it off.
You can, sir. You can.
All right,
Yes,
good.
sir. Yes, sir.
Thank you.
No problem. So I'm just going to substitute the value of b now to be 1 into the function. And I can use any of the equations. Any one of the equations. I just randomly chose equation 2. So it's equation 2, remind you, it's 3a plus b is equal to negative 2. And then I substituted my 1. So it becomes 3a equals this one. I'm going to subtract it from both sides. So it becomes negative 2 minus 1. So it's now negative 3. And then I divide both sides by 3 to give me a equals negative 1. And that's what I would have gotten from a value of e and b. Say it again.
-1, the minus a plus b, that shows. I get -1 and then question myself and say, how much 1 and a then the minus cancel out the minus.
Right. I said something just now that I mean, I didn't say something that is incorrect, but I said something a while ago that I randomly selected equation 2, but the truth is it may be a random selection for me, but there's a madness to the randomness. And let me tell you, for the very question, Andrew, that you just asked a while ago, the statement that you just made, Andrew, it's because equation 1, for argument's sake, is a negative a plus b. Sometimes students will forget that this is a negative a and don't and treat it as a positive a. So I often go for the equation that seemingly is more positive. All right, and which is why I selected equation 2 right at this point here, because I didn't want to make any mistake in my substitution. No, if I use equation 1, would I have gotten the same answer? Oh, absolutely. Absolutely. But you have to be strategic in how it is that you do this stuff. You know, especially if you have a sign problem, you don't want to go with the set up a stuff with the negative signs that way. Because you can get caught. And trust me, those negative signs, geez, please. Yeah, man, them can put you out. All right. If I were to do a quick refresher, personally, I think based on the responses that I'm seeing in the chat, I'm thinking, you know, and I'm not calling any names because I don't want to get myself into trouble. There are some of you who are following. When I say following, I mean, I saw the responses in the chat and you were correct to the T. Really, really proud of you. If you keep up the good work, trust me, you will get your A's. No, let me just warn you off with something. The last iteration of this course I think my highest grade was a B plus. And I got a few B pluses out of the class. If my memory serves me right. I got a few B pluses out of the class. Quite a number of B pluses. This class is larger than the class I had before. I need some A's. I really need some A's. And I'm gonna ask, the only way you're gonna get the A students is unless you practice. I try to simplify what I teach by giving you examples and linking it to the real world so you can understand what is happening. But what is important, you notice what I've been doing up to this question. This question is also a past paper question, am I correct? Yeah, 2010 past paper. Thanks again for those past papers shared with me. I'm going through the past papers and I will, I can't tell you that I'm going to do all the past paper questions, no. But as I go through, as I teach you the different topics, I will go through and select a question or two and solve those questions and come and project them to class like I'm doing tonight. Don't allow me alone to enjoy the working out of these questions and the understanding of the topic. You have to put pen to paper and start working. Students can't wait until I say test time, mid-semester is next week, and then you start studying. Math is a continuous preparation. Continuous preparation. Finally, they are one.
Yes, sir. If you get a couple area wage your lunch money for one month.
Straight up.
Yeah, sure.
Yeah, man.
Sir. Yeah, man, let's serious.
Alwyn, leave me alone now. Yeah, man, you're a good man, Alwyn.
Right.
You're a good man. There are 1, 2, 3, 4 students in the class, 5 students in the class that did not unmute to even contribute to the lesson. And I'm watching you 5 closely because it's not the first time I come to class and don't speak. And I ain't gonna call upon you again to say something.
So call him, sir. Think the bad man, call him.
Me not call them. Them supposed to know why them are here. But the rest of you who are contributing.
Me know, sir. Me want know too.
All right then. You look through that participant list and say to your friend them at all. But the ones that are contributing, I like what it is that you're doing because you're speaking up. I'm getting an opportunity to get into your headspace to see where you guys are at, and I'm correcting those misconceptions. And you are doing pretty well. Students, do me a favor. Over this weekend, I have come to a point in the continuity and differentiability. Sorry, I just stopped sharing because I wanted to just check on something and in the class. I come to a point in the continuity and differentiability where come next class, I am going to, let me see, come next class, all right. Come next class, I'm going to start differentiation from first principles. I am moving. What I'm going to do tonight, I'm gonna, you know what? No, I'm not going to send you the past papers. Nope, I'm not sending you the past papers.
Sir. Any update on Ericosa that Jamaica
yeah, I have some, but it is, I don't think it's for airplay just yet. So I will keep you posted. I promise you, I'll keep you posted. Here what I'm gonna ask you to do for me, guys. I have some questions that I was gonna share with oh, Jesus, what should I do? All right. All right, I'm gonna share 2 past paper questions. I'm gonna share 2 past paper. No, that one can't work. I'm gonna share 2 past paper questions. So look out for them. No, don't do that yet. Don't move it. Let's see if we can share in the groups. I don't have to send. Son, anything just now. Okay. hold on, guys. So give me. It's all right. Let me send because some people would have left and they may not see the question. So let me just send it to Lacan and he can send it out for me. All right. So this is it. I'm going to send 2 questions. Please start working your past papers. Please, guys, start studying. I'm sending you 2 questions on piecewise. The most I'll do on Tuesday, God's willing, is to look at those solutions, and then I'm moving to my differentiation because I'm actually behind now because it is that I'm trying to make sure that you are understanding what is happening. All right. So see if you can catch up on me, please, and we should be good to go. All right. Have a good one.
Sir Sean,
Yes, please. Go ahead.
Then the paper that we share would we tonight. Anyway, you can send that to Lacan of him, shoot that to it.
All right. Okay. Let me fix it up. I'll fix it up. Sure, no problem.
All right, sir. Cool.
Sir, you said you shared the paper in the WhatsApp group or in this chat in the Zoom?
No. I was gonna share it in the Zoom, but
You said you're gonna share it to Lacano.
To Lacarno, yeah. All right. All the best, guys. Later.
Up top, sir.
All right.
Good one, guys.
You too.